All right, guys. Sorry for the trouble. It seems there's two links. So this is the one that you should join actually. So if you know that some people are on the other link, this is where the actual hackathon judging is happening. So welcome everyone. We're gonna start, and people will slowly figure out that there's unfortunately like two lives going on. I don't know actually why it's happening. Not too much problem. It's gonna be all right. So if you can like see that other people are stuck on the other side, like then it's happening here, and everything will be fine. So what will it be about today? Now it's nice to have you, everyone. So as you know, last weekend we had an amazing hackathon all around the world, and today is about electing who will take the final crown, who is going to be the final winner out of all the local hackathon, what happened online, the special project that we picked, and everything wonderful that all the hackers built. Let's get into it. So basically, last weekend on the 28th of February and the 1st of March, we had this hackathon happening at the same time in Sydney, Tokyo, Singapore, Paris, London, New York, and San Francisco, as well as online. And with the help of many partners, we had amazing hackathon, amazing projects, and let's see who got the best project out of all of that. So welcome to those finals. We're gonna quickly introduce, and then we will let the stage for actual builders to showcase their projects. So let's get started. First of all, a few numbers. This hackathon was massive. We had 7,000 registrants. We had on top, counting like online and in city, 1,700, a little bit more than 1,700 hackers. 700 in physical location, meaning like actual building during the weekend, throughout the night, in all around the world, and 1,000 roughly online, which amounted to 550 something projects, which is super huge. So thank you everyone for participating in it. And yeah, there's only one winner, and so let's see who gets the last prize. First of all, this hackathon would not have been possible without our amazing sponsors. So I will ask them to join me while we are presenting them. So some of them will have some of their staff present as final judges. So let's thank them. So first of all, the first sponsor is actually the host, which in this case is us, Mistral AI. So thank you for participating in this hackathon. And with me today to act as a judge, I do have Howard and Pierre. So if you can come on stage and say hi.
Hi.
Hello, welcome.
Nice to be here.
Awesome. Yeah, so Pierre and Howard will act as a final judge and decide out of the project who would like basically wins the final prize. On the second topic, we have weight and biases, of which we have Alex with us.
Hey folks, Alex here from Weights and Biceps from CoreWeave. Super happy to be here. We saw incredible teams from all over the world submit their hackathon projects, and super excited to judge the finalists. Good luck to everyone here.
Thanks, Alex. We have NVIDIA and Ziv with us.
Hey guys, good luck today. Happy for all the projects I've seen so far and looking forward to hear the best project today. Good luck, don't get stressed, and hope to see some good stuff. Thanks.
AWS, we have Arno with us.
Hi, everyone. Nice to meet you. Last week was insane. Ideas were crazy, so I cannot wait for the presentation, and good luck, everyone. So like we could say in Formula One, it's lights out and away we go. So have fun and cannot wait to see the project.
And then some other sponsors on which we don't necessarily have like someone today on the final jury, but it's a research lab that focuses on pre-training, and so they were kind enough to sponsor this hackathon and sponsor a special prize. It's the same for other sponsors throughout this presentation, and most of them are giving special prizes. I know you probably eager to know if some of you or your team won a special prize that will come at the end of this live. So we will listen to all the pitch first, and then while the jury is deliberating on who wins, we will listen to actually who gets the special prizes. So there's a little bit of time before getting there. Hugging Face, from which we have Archer with us.
Hey everyone, very nice to see the community building insane stuff, and eager to see what will be presented today.
We have 11 Labs, which has sponsored a ton of credit for you to build throughout the whole weekend. I've seen a lot of you build with 11 Labs throughout the weekend, and globally, insane quality of projects, but you will all be able to see that in a few minutes. Supercell, I'm super bullish about AI in games. So I really wanted a gaming sponsor, or you to encourage, for you to be encouraged to actually build a game that uses AI. And so this was like the opportunity to cross those two worlds, because I think there's a lot of good things to take from this partnership. And finally, Iterate, our amazing hosts.
Hey everyone. Yeah, nice to meet you all. We were muted. Nice to meet you all. So we were the co-hosts with Mistral of this beautiful hackathon, 7 cities, online version, beautiful platform, as you guys must all have seen. So we basically host hackathons worldwide with the best AI companies, try to make the best experience for hackers and make the brightest minds and the best builders meet all over the world.
Yeah, and we really hope you enjoyed this hackathon. We've put our heart into it, so yeah.
Yeah, a lot of sleepless nights, and we can't wait to see the final pitches.
Awesome. So what's there to win today? Like if you're here, like the builders that you'll see in the project that you'll see, it most likely mean that they got first place in their city, meaning that they already go back home with some cash, some credits on top. But here it's about the global prize, the global winner. And so only one of them will go back with the big prize at the top. $10,000 of cash, a ton of credits, and obviously if they came up so far, it means that they are super good, crazy builders. So like there's always opportunity to hire them on our side. So let's welcome again all the judges. So this is the time where you put your camera on and basically don't put it out until the end. Sorry for you, you're gonna have the spotlight on for the rest of this presentation. Yeah, online participant, I'm seeing a comment on YouTube. Online participant will be represented. Actually, there's winners from first place, like in the cities, winner from online, And we also picked 3 wildcards that we think should have the light on and basically did not win in their local hackathon, but still deserve a place during the finals. So let's welcome the judge on stage, and then we will be able to start with the Tokyo pitch. All right. Let's add Edward from Tokyo, and we'll be good.
Okay, can you guys see my screen?
Yeah, all good. Sorry.
All right. Good morning, everyone. We are Wingfox representing Tokyo. Online dating is hard. Hence, we are 4 single guys spending our weekends in an overnight hackathon. Dating apps have 3 core problems. It's a time sink, endless swiping, and dead chats. 2, they give you no clarity. Most people don't even know what they're looking for. I don't even know what I'm looking for. And there are too many low-quality interactions. In fact, 78% of all users report dating app burnout. Now, I was just thinking, what if your best friend could do the dating app for you? Someone who knows everything about you and can articulate what you want and understand what you need. Someone who can do the swiping for you, pre-filtering chemistry so that you only meet the ones with real relationship potential. Introducing Wingfox, an AI wingman for online dating. We do 2 things here. Phase 1 is we build your persona through date simulations with AI. And you let us, the wingman, run the matchmaking and conversation simulation for you. Phase 1, building your persona. You don't show who you are in a profile, you show it in how you talk. You take a quiz, you go on speed dates, and we build your persona. When you onboard, you fill in a quick quiz, and we generate 3 different personalities for you to go on a speed date with. Powered by 11 Labs, you then go on speed dates. We throw different scenarios, personalities, and vibes at you. As you react, our system is analyzing your conversational nuances. Because it's voice, we capture real interaction style, the same signal you use on a first date. We then observe how you actually respond, your humor, directness, curiosity, values, and build your persona. Now you have your fox, and leave it to us to run the conversation simulation. Phase 2, AI wingman in action. Instead of you messaging 30 people and getting 28 dead chats, your fox or LLM will talk to other foxes and simulate first conversations to predict chemistry and to predict compatibility. Your Wingfox will then decide your best matches. You can then decide to send them a direct message, talk to a real human being, or to warm up and talk to their fox. Now we are going to show you a video demo. Here we have pre-filled a quiz, and you're going to start a speed date with 3 different people.
Hey, I'm Mira. Just got here and my coffee's already looking like it's plotting against me. But hey, at least it's not my life choices plotting against me tonight.
What do you mean your coffee?
Oh, you know, the usual. I tried to make myself some artisanal coffee this morning, but it ended up looking more like sad water. My roommate even texted me about it. I'm really not great at brewing, so I usually just stick to the studio's instant stuff. Classic. Do you usually make your espresso at home?
So Mira is kind of like a very talkative kind of person. Next person,
Hey, I'm Alara. Just got back from a hike where I forgot my snacks, so I'm that kind of hungry tonight. Hope you've got good recommendations.
What are you thinking of today? Sushi, pizza, pasta?
Oh, that's a tough choice. I'm leaning towards something warm and a bit salty, maybe with some interesting textures. Pizza could work, but I'm also thinking about something a bit more unexpected.
So as you can see, this is like a completely different vibe of person, so that we like test your persona here.
Hey, I'm Leora. Just got here, and already my shoes are judging my outfit choices. Wait, no, that's just my cat's side eye from the couch.
Yeah.
Your cat? You have a cat? What kind of cat is it?
Leora is speaking so slow. Now, after all of this, we will analyze your conversations and we will generate your persona. Now, as you can see in the persona, we have a bio here, your personality, and your DNA and everything. And after this, we will generate the chats. Now, LLMs will talk to each other. So all of these foxes will talk to each other, simulate different kinds of conversations, and to see how compatible you are. And based on the different types of trait synergies. So we believe that this product can revolutionize the dating app industry and most importantly, help us find love. Thank you for your attention. Good day.
Awesome. Thank you for your presentation.
Sorry, should I leave?
No, it's okay. There's 2 minutes for questions. There's actually not 2 minutes, but only 2 questions from judges if they have some. So feel free to type or ask any question you may want to have. If there's none, we can just.
I can ask. Yeah, I think you mentioned you're in Japan, right? And the demo is in English, but did you test it also in other languages?
Yes, actually, we first started with Japanese, so we have 2 languages available. So it's live on. We actually deployed it on. On Cloudflare, and we also have the backend with Superbase. So everything is actually working. If you guys would like to get your hands on this product.
Could you talk about the stack that you used? Just briefly. What LLMs, what voices, what everything?
Yes. Okay. So the first thing for after the sorry, I can't find. Yeah. First thing for after the quiz, we will use Mistral's large LLMs to generate 3 different personas, and then we give them as a system prompt to 11 labs. So after 11 labs, we will then open a WebSocket for the conversation while we transcribe this conversation. After the conversation is over, we will send them to Mistral again to generate these conversations. After the Mistral large is used, between LLMs, we'll use the Mistral because we have to simulate so many different conversations. We'd like to keep the cost down. So that we use only Mistral LLMs and 11 Labs APIs.
Awesome. Thank you so much. Now let's welcome the guest from Singapore.
Thank you, everyone.
Sure, my audio and video is visible.
Yeah, your audio is visible, not your screen.
Sorry, yeah, right. Sorry, I'll share my screen. Just give me a second. Let me know if that is visible too. Are we good to go?
Not yet. Let me add it to the screen. Yes, that's good.
All right. So, hi, this is Team Singapore. So we build Babel, a self-evolving tool registry for AI agents. 1 sentence summary. Ask for something. If the tool doesn't exist, Babel creates it. So I'll just keep it simple today. I'll just go through a few slides that we prepared, and then I'll quickly jump onto the demo so that it's pretty clear what we built in the Singapore Hackathon. So the problem is simple but fundamental. Every AI agent framework today requires tools to be predefined before the agent runs. Capabilities are fixed upfront. If something is missing mid-execution, the agent fails, or a human has to intervene. The intelligent can reason freely, but it can only act within what we pre-wired. That ceiling is the problem, and that's what Babel is here to solve. So now Babel is not just an abstraction tool, and this distinction matters. An abstraction layer hides complexity. Babel creates new capabilities. A traditional abstraction layer wraps what already exists. Babel detects what's missing, builds it, and changes the system's capability set over time. What Babel can do tomorrow is not the same as today. So I'll move on. So 4 things that set it apart, right? So at runtime, it detects missing capabilities automatically. It then synthesizes new tools on demand with a formal spec, implementation, and test. Those tools are registered and reused across every future task. And the capability set evolves. The system grows with every interaction. To put it in the right mental model, ChatGPT and LangChain are abstractions over LLM calls, great for prompt orchestration, but no capability layer underneath. MCP standardizes tool invocation, but it's static and has no lifecycle awareness. Babel sits in a different category entirely. It's a capability lifecycle manager. It manages capability state, handles versioning, works across models and stacks, and expands what agents can actually do. Abstractions simply simplify access. Babel expands the surface area. Now I'll quickly move on to the demo so we can see what we have built in this hackathon.
Imagine hiring a contractor to renovate your kitchen, but every time they need a new tool, they have to stop, drive to the hardware store, come back, and only then continue working. That's exactly how AI assistants work today, and it's a massive problem. Right now, every AI agent, every smart assistant you build or buy can only do what it is pre-programmed to do. If it hits something it wasn't prepared for, it stops. Someone has to manually go and build that capability and then restart the whole thing. This is what which makes AI agents rigid, slow to update, and expensive to maintain. Babel fixes this. It's a platform that lets AI agents invent the tools they need on spot. You ask Babel something, if it already knows how to do it, great, it does it. If it doesn't, it figures out what's missing, builds that capability in about 15 seconds, and carries on without anyone stepping in. It's like a contractor who can build their own tools mid-job. Highlighting the architecture under the hood, Babel has 3 layers: a Babel registry, a SQLite HTTP server that stores, discovers, and executes tools; Aria, the planning brain that turns the natural language into directed task graphs and streams execution in real time; and a Wipe tool service, a Dockerized Mistral coding agent that writes production-ready tested tools from scratch. And because every tool follows the Babel format, it works with AG2, LandGraph, Mistral, and Pydantic without any modification. 3 things set Babel apart. First, it never gets stuck. No waiting time for a developer to come fix it. Second, it's private and safe. Everything runs on your machine. Nothing is shared unless you choose to. Third, it gets smarter over time. Every new capability it builds gets saved and shared with the community. So the next person who asks something similar gets an instant answer. Since we have asked to read it out loud in the last query, it streams an audio file using the 11 Labs tool. All the tools that are generated are loaded into the Babel registry, which can be pushed to remote so that other users can also use it irrespective of the framework. Here's what happens when you give me the shortest distance between Chinese Garden to Antler Bugis. Aria, the Babel's planning agent, decomposes your request into a task graph. It finds the tools which are present, but what about the ones missing? So it wipes it, running it in a sandbox Docker container, synthesizing the specs, writing the implementation, and runs the tests all in 15 seconds. It hot reloads it, and there's no restart, and Aria picks it up from where it's left off and executes the full plan. You never see the machinery, you get your answer. That's Babel. Ask it anything.
So Babel is not just a framework, it's the missing layer between intelligent agents and autonomous systems. So thank you. That's it for a demo.
Awesome. Thanks for the demo. That was probably dense. You will probably have some questions.
Right. So I also have my team on the call with me. So we'll try to answer all the questions possible.
You said it runs locally, so everything runs locally on the stack that you implemented, even the LLMs?
No, the LLMs are basically running on cloud, but we have synthesized them into Docker containers. So now whatever happens and whatever calls are being made, they're happening in the container. The testings happen in the container, and then the output is there with you. So the entire vibing section is actually happening in Docker containers, and whatever keys and API inputs it requires from you, those are happening on your local machine. So we abstracted those 2 sections.
Okay.
Do we have any more questions?
If not, thank you for your presentation. And we can actually move on directly to the next one. There's not going to be any question. The demo is going to be directly played. It's a pre-recorded video because those are participants from Sydney. It's super late currently in Sydney. It's 3 a.m. So we allow them to pre-record and not to be present with us. So let's get straight into it.
Every company will eventually face a crisis, whether it's a data breach or a failed launch. The crisis itself isn't what destroys companies. It's often the second decision leadership makes without knowing how the world will react. So a good analogy of this is pilots don't fly without simulators, and we believe companies shouldn't either. That's why we've built Ripple, which is a crisis time machine. It simulates how stakeholders in an environment respond to your decisions before you make them. Here is a real scenario, an actual scenario that happened in Australia, but we've sanitized it. Let's call it Mistral. So Mistral discovers unauthorized API access that it could potentially, exposes millions of customers' data, and leadership receives an email from the hacker in question. And you can see how this can lead to billions in damages and how it can cause reputational damage and even take years to recover from, and you can see how it propagates down. So in scenarios like this, what does leadership do? What if you could time travel to the consequences of your decisions before you make them? That's why we've built Ripple, which is a multi-agent simulation engine, where each stakeholder is modeled as an independent agent, and they have memory, incentives, dynamic state. They can interact and amplify signals in the simulation and cascade their reactions across the system. So let me show you how this works. This is the Ripple dashboard. Let's create a new simulation with the scenario I just described. And here it's building the environment. So you can see it's even scraping company data, and as you'll see, it'll build the world that'll run the simulation in. So here's a summary. All of this is editable. There's audience cohorts, which you can edit to, and even context sources. So this is what it's scraped based on your company. You can even add internal company sources, and this will essentially enrich the world building of the simulation. And here you can finally select the simulation duration. We'll go with 3 days. So as we run this, you'll see there's nodes. Each node represents an audience cohort or an actor cohort. And then on the left here, you'll see individual comments from the agents within the cohort. So this is the first human in the loop decision, whether we'll disclose this or keep it internal. And as you'll notice, there's preview buttons here. If we click on this, you can see a brief overview of how this decision could ripple into the simulation and what effects, downstream effects it could have. This is not completely accurate because it's run with a short tree depth, but we'll select this one for now. And then you can see how it has affected the simulation overall health score over here, and even introducing new actors. So here you're getting comments from the public, and as you'll notice, these comments here are fine-tuned on Mistral small models using social media data just to make the responses more accurate. Here's a second human in the loop decision. We'll just select this one for now. And yeah, you can see how it affects the overall health score. One thing I'll note is with each of these simulation paths, we're running multiple in parallel, and then we average out the score, so it makes a more robust prediction. So here's the final output. So this is a report that it generates, and it gives you an overview of how you did in the simulation, the final health scores, key moments, what went well, what went wrong, and then finally some recommendations for mitigations for the future. Let's say in reality, on day 2, something different happened. So for example, a hacker demanded a ransom.
Nick, I think your video dropped up just now, the screen sharing.
It dropped again?
Yep. Can we resume the...
Okay, should I just continue? So here I've just injected a scenario where in day 2, hacker demanded a ransom. So you can now decide whether to refuse payment or do another action. So let's choose this one here. And you can see how this real scenario has propagated and changed the scenario for the simulation. Yeah, and then you can see on the left here how it changes how the actors in the simulation act. And then finally, here's the simulation report. And let me just walk you through now how what works, how it works behind the scenes. So behind the scenes, it's a simulation engine powered by Mistral, and each agent is a simulated individual. So each of them have their distinct memory, personality, and they act in their own way. So they're basically independent, and they react with each other. And then, as I've mentioned before, there's a fine-tuned Mistral model specifically for the to replicate the general public. And then finally, there's an orchestration layer, which is using a large Mistral model. Now, we believe that this introduces a new category called decision simulation engines with agents, and it's a new way for organizations to rehearse and kind of interact the future before they act. And in the real world, you only really get one chance to respond to a crisis, and we believe Ripple lets you test that.
All right, that was it. Unfortunately, so this was the winner from Sydney. There's no live Q&A, obviously, since it's the night. And as you've seen, it was pre-recorded, but for fairness, only gave them one try. As you've seen, they lost connection in the middle, but it was still in the recording because it's an online contest. You have to be fair. There's only 5 minutes to pitch, so it's those 5 minutes that stay. So if now we can welcome the person that did win online. So Ram, I think this is you.
Hey.
Hey, both of you. Can you share your screen? And then let's move here.
I guess he's okay.
Ram,
he's supposed to share the screen. Okay.
Okay, Fami, please share the screen.
Hello.
Hey.
Yeah, can you hear me?
Yeah.
Sorry.
Yes, let me add the screen to the main window. Normally, I think it should be fine. It's not your screen showing.
How much should I?
Let's try to be faster. Otherwise, I'm going to share your presentation and you can talk over it. All right.
Hey, thanks.
I'm going to share my screen. No.
Don't worry, it's like presenting live, so
yeah,
that's normal.
So
it happens to everyone.
Yeah. Normally you can see my screen. So yeah, you can go ahead. I will switch slides.
Okay. So I think for me is not there. So I should present the entire thing. So actually we were trying to present it half like that.
Please just go ahead.
Yeah. So can you start from the starting?
Yeah.
Yeah.
Sorry, this is a headache. This is weird. This is not this. Okay, go ahead.
Yeah. So hi everyone. So our project is Mistral Right, which is entirely a dynamic game that will be not scripted end to end. So the basic idea is all the boss and the demons in the between the design and every stuff. Okay, I guess Fami will continue.
Yeah, I'm in right now.
Yeah, cool.
Guys.
Okay, it's better. I will start. Sorry, guys. Okay. Yeah. So good evening, everyone. So our project is Mistral Right, which is basically the game which is not scripted. So basically, the boss is very dynamic, and it will be real time analyzing your gameplay. Not only gameplay, also your voice feedback. So basically, when the player starts this game, it starts from watching you from the starting. So it tries to listen to your voices, whatever you speak, and everything, and also give a dynamic, real-time feedback and a kind of debate situation kind of thing. So this is the main idea. So we'll start with a quick demo, and then we'll go forward with the tech stack and everything. So yeah, someone next page.
Yeah.
Yeah.
They called me mad, to defy fate itself. But what is madness facing such profound grief? He just missed that critical hit. Unlucky.
You are testing me. You are not afraid. You are curious. You do not fear the fight. You fear the idea of failing. That is why you stand. That is why you wait.
That's all you. That's all you got.
You ask what I have. You have not yet asked what you carry. The weapon is not the question. It is the all 88PX retreat. The space between you and the unknown. You seek understanding, not combat. You are not here to fight. You are here to learn.
So you can skip a little, Simon. Okay, it's at the end of.
You fight like someone who expects the world to be fair. It is not.
All right.
Yeah, we can go to the next slide. So basically, the whole game is controlled by 4 agents that will be running simultaneously the entire time you play the game. So they will be watching you. So the main agent is the architect, which will be trying to collect all the user audio with the help of Voxel, which will try to convert it into text. And also it will be analyzing your telemetry, like the player position, movement, pattern, and everything. And also we've added a small feature, like it also has access to 11 Labs custom voice changer. So basically it can actually change the voice dynamically based on the HP of the boss or like whatever style you're fighting. So that is the main goal of like work of the architect agent. And then comes the dungeon director. So dungeon director is a less frequent analyzer, which will be analyzing in a particular time period and tries to control the difficulty. And also even it can go further to design the custom levels kind of in the upcoming levels. And then we have a dungeon companion, which is a small chat box, which is present in the left corner of your gameplay, which will be both activated via text and voice. So you can just it can just basically help you in solving puzzles and kind of stuff. And also we finally have a AI co-op partner, which is kind of a secondary player, which is fully controlled by AI, which will be playing along the whole game along with you. The basic motive of this is now the project is in prototype, so we have some little features like it will try to solve puzzle, give you weapons, and tell you or like tell you where the enemies are coming from, like that. So yeah, Simon, next page, please.
Yeah, we are much over time. Sorry, we'll switch directly to the question. You had 5 minutes. This is sorry, but this is only.
If you give me 1 minute, the last slide. Okay, so also the game is generated dynamically with the help of Mistral. So the player can give a prompt, and then Mistral will summarize a carefully crafted JSON file, so that this JSON is. Oh,
let's move to questions. Yeah.
Sure.
Is there any question from the jury?
Yeah, can you speak to some of the technology that you use to build this?
Yeah, so the game is generated using Stable Diffusion from Hugging Face. So basically, user can provide a prompt that will be helpful to create the game. So basically, it is so customizable that the player can design its own level, weapons, loot, and everything. So Mistral model will try to create a JSON describing all the patterns that the user is trying to make, and then Stable Diffusion will generate them, and we have our game engine to collect all the assert and create a gameplay. So that is the game design. And apart from that, we are using various models like Mistral Large, Small as a fallback, Voxtral to gather the speech, and also 11 Labs to do a voice changer kind of modifications.
Awesome, thank you.
Thank you.
So, do we have Olivier with us? Yes, I think so.
All right. Hey guys, can you hear me?
All right. Yeah, we do.
Awesome. Can you see my screen?
Not yet. It's on the way. I think.
Let me try showing again.
Could you present the team? Where from the team is?
The team here is from London. So basically, in the top right corner, you will see the icon that represents the city.
All right. Do you want me to start?
Yeah, just wait a bit. Yeah, all good. Maybe let me try this presentation first. Maybe we will see better. Yeah, let's go that way.
All right, sweet. All right, well, hello everyone. Nice to see you all. My name is Oliver, and we are the London Hackathon winners. So, what do we think happens if we give AI agents money, land, personality, even political power, and then just take our hands off the wheel, let them run? So last weekend, we built Mistralverse to try and find that out. So Mistralverse is a fully autonomous, persistent AI civilization where every single citizen in this civilization is a Mistral agent with its own personalities, jobs, opinions. They even trade, they talk to each other, they do import, export. We even saw them vote democratically to elect a mayor to run the economy of this civilization. And this runs 24/7, whether you're watching or not. But if you do want to watch, if you want to see what life is like inside of a world run by AI agents, you can also join as a human and play in this city. And your interface for doing this will be a Mistral Agent 2. So let's jump into it and see what it looks like. So we're loading into the city here, and it's pretty cool. Every single building you see here is generated by AI agents. And so we have construction workers, and you see them driving around and walking around, which is pretty cool. Now you can also join. So if you prompt here, we see we want to build a gas station. It asks how many iterations. And what it will do, it will call an image model. It'll get the blueprints for this building, and then it will send those blueprints to our construction agent, who will then generate 3JS code. And we have an iterative loop. So we also have like a feedback agent that will look at these buildings and approve whether it's good or not. So that's the construction for you. And we also have a fully an economy for the whole city. And so you can see on the top here, we see the treasury, we see happiness, we see crime, approval ratings, and we're watching a ship come into the dock here. I think this is pretty cool because it means that the economy isn't zero sum. It means we're actually doing import and export with other cities, such that we can see the economy grow and we see growth in the city. So we actually left this running overnight, and we saw buildings being built, and you can see the cities bustling. We also see agents being paid based on what type of buildings they do, and so they'll get spawned in with different archetypes. And if you're industrial, you might make more money. A little funny thing you just saw here as well is a luxury casino. We found we left this running overnight, and they just built a bunch of casinos. We're not sure why, but it turns out Mistral agents love casinos. So that's a fun little Easter egg. Let's jump to the next slide. So we also have a government. So I mentioned they democratically elected an agent to run the economy, and this agent can collect taxes, it can approve or reject building applications, so it actually has control over what cities, over what buildings are being built in the city. And we can see here that the economy went bankrupt. And if that happens, they will actually kick out the mayor. So we saw Barnaby Suits, the agent here, just get kicked out. We see them keep talking, and then boom, they've elected a new mayor. So now Ada Ironwright, the agent, is now running the economy, which we thought was pretty cool. Different mayors had different policies because they spawn in with different personalities. But overall, we found AI is pretty bad at running the economy. But it was a fun little dystopian thing to see. And then lastly, you can join in. And I mentioned the interface is a model in itself. So you just have a chat interface. You say, I want to drive a car. All of a sudden, you're driving around in the car with all of these agents. And the same thing, if you want to fly a plane, you can say, I want to fly a plane into the chat interface here, and you will get put in a plane and you can fly around. So we got a bit of feature creep building this, but we did have 30 hours and we wanted to make it fun. But yeah, that's pretty much it for the demo. You can see us flying around, and you see there's a bit less buildings here. The reason for that is we filmed these demos earlier on while the civilization hadn't grown enough. So this can actually run 24/7. So it looks a bit whimsical. So let's maybe talk about why this actually matters. I think there's 3 points. The first thing is this was genuinely super fun to play with. We lost a lot of productive time that we maybe should have spent making the project better. But the reason for that is it's a new interface, right? So instead of walking over to a car or going to a plane, you can just tell it, hey, I want to fly a car. Sorry, I want to fly a plane. And now you're flying a plane. Or, hey, I want to build a skyscraper. And it will, your little agent will hire a construction agent to build that skyscraper on your plot. So that was pretty cool. Secondly, it's a simulation tool. So we can actually simulate societies. We can see how economies work, how societies work. We can change the incentives and see what happens. And so you could do a lot of experiments in economics or in politics around that. And lastly, I think my personal favorite is we saw this become a whole new kind of model eval. And so if anyone's been watching the news lately, there's a lot of talk about using AI in warfare and these kind of dystopian concepts. And it's becoming more and more important that AI is actually aligned with humans. And I can't think of a better way to see if a model is aligned with humans than to just let them run their own societies and see what happens. And I can promise you, they're not ready. We tried different models running these economies, and they always crashed. Crime went up, happiness went down, and they had to re-elect mayors. And so it's a really interesting model eval. And then a little bit on how it's built. So obviously, as we mentioned, all of the citizens are actually Mistral agents that can talk to each other in that chat view, and they can do their thing. We have a AWS Bedrock API that we called for the construction agents. We use the Mistral API for the citizen agents. The backend is convex. The pipeline I already went through, and the economy engine. We basically have the treasury. We let them trade. If the treasury is good, if the economy is up, happiness is up and crime is down, and vice versa. And that is pretty much it for the presentation, I think. So I don't know if we want to jump into questions or what.
Definitely.
Well, I'll go ahead and just ask a small question. Did you test other models apart from Mistral? And if so, did you find like very notable differences in behaviors? So you mentioned they were bad at running the economy, but like what was like the traits for the Mistral models compared to other models if you tried them?
It's a good question. So we found out because we're running right in the civilization, there's about 100 agents in parallel running, and so the token costs are immense. And so while we did plug in different models, we couldn't out of our own pocket afford to put in Claude and let it run, or GPT to let it run. So we really only tried it with like a full long running simulation with Mistral API because the tokens were subsidized through the hackathon. But I'd like to think we'd see a different picture if Claude was running it, or maybe like a Grok 4.2. And so it's an interesting question for sure. And this is kind of the simulation tool we talked about, right? Or the model eval thing. If you plug in different models, you can see how they behave over time. Yeah.
And what success factor or metric would you qualify to say it's a good model or a bad model? And subsequently, did you observe some weird exploit or bad behaviors that might mimic what humans do or not?
Yeah, I mean, I think for starters, for starters, I think if the economy doesn't crash, that'd be a good start. We saw every model and every agent elected end up crashing the economy. In terms of weird behaviors, I think the first one is what I pointed out, is there's a weird amount of luxury casinos. And then on the flip side, there's a weird amount of like medieval taverns and like medieval buildings. And so you had some pretty interesting neighborhoods when it was running. We also at some point saw a Mistral agent get selected that was very into green energy and didn't care about anything else. And so we saw in the chat a lot of agents that weren't into green energy get pretty mad because they weren't allowed to build factories. Ultimately, the economy collapsed and they elected a new mayor. But it's cool to observe those kind of dystopian things, especially when you have the chat window, because you can actually see what they're thinking. Any other questions?
Maybe one quickly. I don't know.
Yeah, go ahead.
Okay. Did you use a specific patterns like Swarm, like agent as tool, or whatsoever in the architecture between your different agents to communicate between each other to build up the economy and stuff like this?
We literally just gave them a chat, and so like the way they can interface is just through like an MD file or anything. We didn't use like a specific protocol for this, but I reckon you could set that up and make it more robust. At the end of the day, when you have 30 hours to build it, it doesn't become that polished. But there's definitely ways to make it, more scalable for sure.
Yeah. Thanks.
Awesome. Thanks, guys. Appreciate it.
Thank you. So I think we can have Godefroy from Paris. Hi, Godefroy.
Hello. Let me share my video, maybe.
You don't need. I already had it to the next slide.
Okay, that's
so
fine.
if you're ready, I can switch to the next slide and we can get started with Paris winner.
Yeah, that's fine for me. You can put the video, Geoffrey. That would be nice. Okay.
Let's go then.
So let me present you Veristral. So Veristral is an app that we developed. So misinformation, as you may know, travel really fast. Like when there is a fake news, it's very hard to debunk because a lot of people have seen it before having seen any fact check. So in order to bridge the gap between fake news and them being fact checked, we created Veristral. So what it will do is that it will correct false data as it's put on screen. So how does it work? So we have two instances of OBS. The first one will send the audio to Veristral real time. And this will allow us to use a transcript in order to create a workflow with temporal. And then in this workflow, we will use Mistral in order to classify any statement to see if it's wrong, if it's misleading, if it lacks context. And we can also use a RAG database in order to pull anything that has been said by a politician, for example, and to see if he's contradicting himself, for example. So once we know whether the statement has to be corrected or not, we can put a small window on the streams that will arrive on your TV with our second instance of OBS that is displayed live. So soon I will show you a video, and what you will see is you will see our backend. So you will see Emma, which is one of our team members, doing an interview. And then I will show you what it would look like on the TV, because I will switch room and you will see the streams that she was doing with a 30-second delay and the fact-checking in real time right as the sentences are beginning. So in a few seconds, you will see that. Yes, okay, let's go.
My dear fellow citizens, the time has come for a clear signness in the face of the historical challenges piling up before us. The 2022 presidential election
The statements which lack context are in yellow, and the fake one are in red. You just are doing the interview. So you just saw Emma do a political interview. And now with Veristral, she will be fact-checked on the delayed stream. So the stream is delayed by 30 seconds, and it's arriving on the TV. And now we will go check the TV, and we will see that when she makes a wrong statement,
we are live, by
she's
the way.
corrected. So let's see. That's your TV.
In the face of the historical challenges piling up before us, the 2022 presidential election.
And you can see when she starts a sentence, if we need to add context or if it's false, there is a small window to correct.
French economic growth in less
If she says something true, no correction needed. So you can see she's making some statements which are factual.
577 members of parliament, the French people are not satisfied.
So she's playing kind of the populist.
Today, unemployment is skyrocketing, affecting 40% of our working population. This is a true human tragedy that is destroying our families.
I don't know if you can read, but for example, the statement was that unemployment rate is 40%, which is false.
Of this decline, which is by no means inevitable, especially when we know that France contributes.
So she made another wrong statement, and instantly you have a window. It's correcting her.
This is unacceptable. I'm outraged.
And now another one.
The monthly minimum
so the minimum wage
in
in France is not 200
is
euros.
200 euros. This is untenable. I promise you, I will change things. Back together starting tomorrow. Let's take back control of our national destiny.
So you can see
there was a small black screen over the window, so that's because we use Zoom to display it on TV. It was a stream through YouTube. So now regarding what we built, so our agents, how much can they detect fake news or not? So we tried on a few statements, about 80 of them, and in 70 cases, it was compliant, and in 10 cases it was not good. So of course, it's not a final product, but we thought that 87.5% accuracy is quite good. Also, all of this pipeline is happening in 12 seconds in average, and the max we saw is 23 seconds when we do a lot of RAG requests to check previous statements, for example, and when we do web search, which is often the case because we want to have sources when we correct a statement. So yeah, the objective is that to use AI for good, because as you may know, a lot of people are making like fake content with AI, and it's hard to check them. And what we want to do is to add some positivity and to use AI for good in order to make the political debate more transparent and to have better policies for everyone. So thank you for listening. If you have any question, I can answer them.
Hey, Godfrey, great presentation. I have a question about the facts and the demo. Emma's reading the demo, and she had like strongly misstated facts. Did you guys input this ahead of time in the transcript, or is this on the fly? And if it's on the fly, what backend are you using? Because like nobody knows what the truth is, right? Even if you do like a search API, you can hit something that was as wrongly misled as she's saying this. So how are you actually fact checking? Is the model hallucinating the facts? Are you backing up with some search?
Okay, so that's a few questions, but I will answer them. So first of all, yes, it's in real time, and yes, she could say anything, and she could be fact check on that. We could do a real time demo if you want, but like it's a few minutes of setup for this. But yes, that's real time. She can say whatever, and it will be corrected. It works in French and in English. And how do we know if it's fake news or not? So for that, we will do a web search in order to see if the statement is true or not. If the AI first of all thinks that it's true or not, because because it's an LLM, it has a lot of information already, so it can see if it's a statement first of all. So if it needs to be corrected or not. For example, if you say I like banana, we don't mind. We don't have to correct you on that. It's your personal taste. But if it's something that is considered to be a fact, then we check it. And for that, we use web search. And what we want to build is for a specific politician. We do a RAG database in order to see any previous statement you have made, for example, on Twitter, on a previous interview. And if you contradict yourself, for example, you say, I'm pro something, like 2 weeks after you said I'm anti something, we will say, okay, so the previous statement by this politician stated that he was against that, and now, he's contradicting himself, which can be fine, you can change your mind, but we want to be transparent about like people trying to bamboozle everyone. Okay.
Thanks. Thanks for the presentation. Thanks for the question. Now we can move on to New York.
Thank you very much.
Let's New York. If you have your screen ready,
Yes, just making my screen ready.
Yes, I can see your screen. Let's move
Come
to.
Okay. Are you guys able to see my screen, by the way?
Do I go into the...
We're going to a nice scene, and it's going to be okay.
Oh, it's like I'm showing my slides. Are you able to see?
No worries.
Oh,
Correct here. Yeah, good.
Oh, you're able to see my screen? I'm kind of. Oh yeah. Okay. So I think I hope you are able to see my screen. So my project is about an EdgeAI agent that runs on your local machine, and I'm running this on an NVIDIA Jetson Nano Super. So it does. The aim of it is it will try to learn your patterns because of the events that are happening previously, and also the episodes and everything, the interactions you make. Try to learn from it and fusing all the sensors in the room, trying to make an intelligence where it can predict your needs, like it can predict your needs or it can adapt to your needs. And the LLM acts as a decision maker, but the decisions, actions, everything will go to policy agent, so that you don't say whatever LLM says. You don't execute whatever LLM says, because LLM is a black box, right? So everything will get clear once we get into the video. So most smart homes and everything, the issue we see, the privacy, most of them have issue of privacy where we can't use, where we can't, like, users are afraid of sharing that data, right? And it's no memory or preference. We don't have any preferences and everything that are stored in our smart homes and everything. And no safe ground, safe decision loop, whatever something gets wrong, what to execute and everything. Okay, let's go through the video so that you guys will get much more clearer on
This is
it.
my video demo for Mistral AI Hackathon.
Oh, okay. This is the video. Playing it now.
This is my video demo for Mistral AI Hackathon. Let's start with the demo by entering the room. As soon as I enter my room, the lights get turned on. This is due to the door sensor and the MM sensor over there. Let's start with the bedroom agent now. Okay. Let's ask it to run a bunch of commands. I already kept the commands over here.
Oh, I'm sorry about that. Just a minute. I'll try to. I think it's the wrong video that's being played. Demo presentation. I'm sorry about that. Okay.
Yeah, hi. This is the demo for the Mistral AI Hackathon. We have a bedroom agent that we are trying to demo. Let's start going to the room and explore the agent. So, as soon as I enter the room, the lights get turned on. This is because of the window sensor and the MMware sensor over there, which is infused in our agent logic, which switches on the lights. Now let's go through all the components that are used in this project. If you see over here,
Okay, wildcard 1 is port.
Nano, that's running all of these services. We have the LLM, Mistral LLM, that is running on this. We have the agent. We have the Zigbee services. We also have Home Assistant. We also have Piper and Whisper running. This is hooked to Zigbee controller, which controls all the. We have MMware sensor, we have temperature sensor, and also we have the smart plug over there. So, and we also have an IR blaster for controlling the AC. Now let's see the agent in action. Our agent is, you see our agent is running over here, and for this I'll try to control using Home Assistant, using Assist or using Whisper. I'm feeling very tired now. Okay, if you see, there are a bunch of actions that ran. The AC temperature got set, and
basically understands your intent.
the lights got turned off because of the sleep mode. And the AC temperature is actually set to 24 degrees Celsius. Let's make it a little bit warmer. Can you make it a little bit warmer next time?
So it understands the context that it's previously happened and updates its preferences so that it's
okay. What's the preferred temperature?
So preferred temperature is the temperature that we just modified. So next time it uses that temperature to set the AC temperature.
See, it got updated to 25 degrees Celsius instead of the 24 degrees Celsius, which we already have. Let's switch on the lights.
Sorry, who is the most liked
I need
project?
to work right now.
Sorry. We need to stop here.
So focus.
Your overtime. And there's a Nico also.
Okay. Is there any questions or anything that you guys have? I can just go through this, the Jetson Nano that it's running on and everything. And this the model, why the model is, why I'm deploying this model. And this is the camera snapshot that it takes, that it analyzes and gives information about whatever question you have. If you have keychain that's in the room and then you go outside, you can ask it, okay, is there any keychain that I left in the room? Are the doors closed or these closed and everything? And this is screenshots about the preferences and a bunch of other scenarios that we have. Focus mode, like why did you just do it? It just answers based on all the events and episodes and the data that it has previously. And yeah, future wave sensor, it's good for sleep tracking. We can use it for sleep tracking. I'm planning on using it for, I actually use it for my room, most of these things. So this is some of the info. And wanted to make it the memory architecture more three-tied architecture, like MemGPT or like Hindsight, and make it more agentic.
Hey man, sorry to interrupt. I have a quick question before we move on to the next one. Super quick. What is a funny thing that it did that you didn't intend to? Was there like a funny moment that you asked the AI to do something and like your lights flickered or the dog got locked or something?
Yeah. No, actually, like most of the actions, what I made was the intent is grabbed by the LLM. Most of the actions that we are, it should be run by a policymaker. So it doesn't actually like make any wrong actions. It goes to the flow. But if the intent is wrong, sometimes if I ask, okay, decrease the temperature, and it will say, oh, comfort mode. Okay, I will enable the comfort mode and run AC for like 21 degrees Celsius. And I'm like, okay, I don't want comfort mode right now. And it does a bunch of funny things like that. And there are sometimes the bugs that we usually have. I just used to fix everything in my like whatever. And yeah, once the sensor got off, like the wave sensor was not working well. I was in the room, but it stopped. It switched off the lights. It was a finicky thing. Then I had to like enable the AI spatial mode. I'm using Akara FP1E sensor. It has like an AI mode where it learns about the surroundings and interference and everything, so that it gives good accuracy. Yeah.
Awesome.
Thanks. Let's move on.
Okay.
Thank you.
Okay. Thank you.
Thank you so much.
Thank you.
Let's welcome San Francisco.
Hello.
Hello. Can you share your screen? Yeah, all good.
Okay.
Let's wait a bit before we start. We see your screen, but it's not yet the right source.
Okay, whenever you tell me.
Yeah.
Am I good to?
All good.
Perfect. Thank you. Yep. So my project is called Drumworld, and it's an interactive storybook to make kids draw and create their own story on the go. So let's straight jump to the first video, because I think it's very visual and you will get an idea of what this project is.
Welcome.
Okay, so as you can see, the main
How
idea of
old
the
are
project-
you?
Yep, the main idea of the project is create something for kids, something that has AI hidden behind it, but also that can exploit all the capabilities of the Mistral models. In this example, you could see how the app is really visual and it's meant for kids. So in a nutshell, the architecture, how it works is you have the child input. We will see that that can be a drawing or it can be a voice note. Then we have a vision layer or some kind of layer that interprets what the kids want to do. And then what I have is an intelligent agent using Mistral large model that decides how it is going to build the story. So I've given him 5 tools: generate a paragraph, generate sound effects, request drawing, request speaking, or finish the story. So in every iteration, it is going to decide on the go how the story is going to continue. So every story is unique, and the kid is going to choose how the story is going to develop. At some point, it is going to decide, okay, for this next segment, I need you to say what word our main character is going to say. And based on that, the story is going to keep going. So here in the next video, we will see a quick demo of how the kid, for example, is going to be drawing a chicken. And based on that, here we can see the debug screen where we can see the AI agent in real time deciding how the story is going to be created. As I said, it can decide to create music, the soundtrack, sound effects, and the sounds that the main characters are going to be doing. It is also going to create a drawing of the paragraph that we are reading at that moment, and it's going to create the voice using 11 Labs. So we have like a narrator telling the story. That functionality can be turned off. So in case that the kid is playing with their parents, the parents are the ones reading the story. So this is again the screen we saw, and we can see the agent deciding what it's going to do. For example, here we can see how it decided to create the background music, the soundtrack, then the first paragraph, the sound effect, and at some point it's deciding for the kid, it's asking the kid, okay, you said something, how is the story going to continue? And once we know how the whole application works, this is the demo. We have
One bright and sunny morning, a tiny yellow chick named Sunny peeped out of a cozy nest. The warm breeze tickled Sunny's fluffy feathers, and the golden sun smiled down from the sky.
We can listen to the background music. And there we can
Sunny stretched their little wings and looked around. The meadow was full of tall swaying grass and colorful flowers. But something strange caught Sunny's eye. A tiny, wiggly creature moving near the nest.
Yeah, again, we can see the paragraph with the voice and the sound effect. And now, at this point, for example, the agent decides, okay, how should the story continue? What is our chicken going to tell the new friend? In this case, it chose to ask for a voice note, and it's using Veristral, the AI model. But it could perfectly, and as I have in this example, it could ask, okay, draw what is going to happen next. Draw what the character is. Draw this one too. So the story is interactive. At some point, the AI agent decides, okay, let's end the story, and it finishes it. So that's the main idea. Thank you.
Thank you so much. Let's move on to questions now.
Have any kids?
What ages? Yeah, maybe.
Go ahead, Steve. Go ahead.
Sorry, thanks. Just about the ages, because obviously kids, you know, they talk differently. They throw words in different languages. Like, how does it helps kids or encourage kids to interact with this? Is this on the orchestrator or that's something else in the architecture?
Yes. So the main idea is for the kid to be playing with it, but also like a parent having the supervision of it. At the beginning, you can draw your own age, and based on the age, it's going to tune how the story works. So, for example, if the kid is really young, maybe it asks more about drawings rather than asking the kid to speak. If the age is old enough, for example, 9 years old, it's going to make the kid talk more. Also, depending on the age, it's going to tweak the words, how complex the story is built, more simple or more complex. And yeah, about the voice notes, it's using Voxtral, it's transcribing it, and then giving it to the orchestrator. And based on that, it's going to decide, okay, with this word, this sound, or this paragraph, or
Did you test this on any actual kids? I noticed that transcription for kids, especially AI transcription, is not that great with LLMs.
yeah, me myself, I haven't, but I had some friends I met in the hackathon that actually they had access to the repo, and they sent me videos of them using them with their kids, and they seemed happy, like they liked it. I had 2 videos, and yeah. Thank you. I don't know if you have more questions.
I think this is all. Thank you so much for presenting your project. Let's move on to now so those were the winners of the local hackathons. Now let's move on to like the wildcards and the most like project. Basically, this is a hackathon. There's always a a component of votes, a component of project that were undervalued. So this is where we leave the stage to those projects. So the one that we will welcome now is the one that did receive the most number of like on the platform, Hevinesh. And later on, we will see wildcards, so projects that we selected to be part of this final with us.
Hello everyone, I am Vignesh, UG student from India. I would like to take a moment to thank Mistral and Hugging Face for always being part of my college projects and contributing to some of my hackathon wins. I am presenting my project TB Guard XAI. TB Guard remains one of the world's deadliest diseases, accounting for around 1.23 million deaths per year, and yet awareness is lower than other diseases. In many regions, there is a severe shortage of radiologists, sometimes fewer than 2 specialists per million people, which lead to delay in diagnosis. Even when clinics have X-ray machines, it takes hours to get X-ray interpretation. Existing AI tools rely heavily on internet and also lack explainable outputs. In the rapid growing AI era, one of the challenges is trust. Many clinicians are cautious about relying on AI for medical decisions. My goal is to help change that by building transparent, explainable AI systems that clinicians can understand and trust, while also raise greater awareness about tuberculosis. Tuberculosis TB Guard XA assists clinicians by prioritizing high risk TB cases and not by replacing them. Now, coming to the solutions slide, I built TB Guard XA, an offline first explainable AI system designed to assist clinicians in TB screening. The two key features behind the system are offline first AI screening. A lightweight deep learning model runs directly on clinic computers, allowing chest X-ray images to be analyzed instantly. This means the system can still function even in areas with limited or unreliable internet connectivity, which is common in rural healthcare settings. By performing the analysis locally, the TB Guard XA reduces dependence of expensive cloud infrastructure. And the another feature will be explainable and intelligent assistance. Instead of just providing a prediction, my system generates GradCam heat maps highlighting the lung regions that influence the model's prediction. This helps clinicians understand why the model predicts TB, improving trust and interpretability. The system also estimates prediction uncertainty, so ambiguous cases can be flagged for further expert review. Now coming to the workflow. First, my system will be gathering the patient symptoms along with the chest X-ray and then analyze it with deep learning model. And then it will be determining the confidence score along with the prediction of whether the chest X-ray is positive or not, like whether it has TB or not. And then my system will match the chest X-ray and the output with medical guidelines from World Health Organization. From all these outputs and also the GradCam heat map, the synthesis of Mistral will take place along with the findings from all other steps. After Mistral done the synthesis, Gemini will be used for validating the output, and then final clear report will be produced. Now coming to the architecture, the input layer will consist of chest X-ray input along with optional symptoms. The symptom can be text or voice, which will be processed by Voxel real time. Then the chest X-ray will be taken as input for deep learning ensemble model, which consists of DenseNet, EfficientNet, and ResNet. The chest X-ray will also generate GradCam heatmap overlay. In this step, there will also be a process of uncertainty quantification taking place using Monte Carlo dropout algorithm. After this step, we will get primary outcome, which consists of prediction, TB probability, and confidence. Then we will be using Mistral embed model and save the vectors to QRAN to vectorize World Health Organization guidelines and literatures. Then the WHO guidelines, the input chest X-ray, the heat map, the primary outcome, all these will be sent to Mistral Large 3 model, which begins its multimodal synthesis and will draft clinical synthesis for patients based on their age. After this, the drafted clinical synthesis will be fact checked against all the outcomes and also RAG and its analysis, and the feedback will be again sent to Mistral, and after few cycles of correction from Gemini, the final validated output will be generated as PDF. Now I would like to share my demo.
So Vignesh, you have 20 seconds left.
In this demo, the user will be inputting the chest X-ray image. After that, they will be selecting the age of the user and also will input optional symptoms. And then after AI screening is started, it will take the chest input image along with symptoms as input and will first pre-process and then use deep learning model consist of 3 ensemble models for producing the output. Here it will produce primary prediction, which is positive or negative, and then probability, confidence, and uncertainty, and also the GradCam heat map. And now, based on all these inputs, the comprehensive clinical synthesis will be given by Mistral and Gemini.
Okay. Thank you so
Now
much,
I would like
Vignesh,
to
for your
switch back
pitch.
to the.
We'll move to the questions now, so the jury has some time to.
Now coming to the results, I done the internal test evaluation for.
Vignesh, can you hear us?
I done the internal test evaluation on 4,200 images out of 15,000 training images and got accuracy
Vignesh?
of. Yeah.
Yes, we're moving to the questions now.
Yeah, okay.
Okay. Please go ahead if you have any questions, jury members.
Maybe what's the stack that you implemented behind the hood?
Like I have used DenseNet, EfficientNet, and ResNet for deep learning model, and have used GradCam++ for interpretability to produce heat maps, and use Monte Carlo dropout for uncertainty quantification, which will give us uncertainty based on 20 sampling it will generate, 20 prediction it will generate, and based on all those predictions, it will be taking mean and tell us whether the output is uncertain or certain. And then I have also used QRAN VectorDB for and Mistral embed for vectorizing the clinical the evidences from World Health Organization, and this all will be finally generated output will be come from Mistral Large and Gemini validation.
Okay, thank you so much. Let's move to the 3 last projects now. Thank you, Vignesh. So the 3 last projects are the 3 wildcards. The first one is going to be Portworld from Paris. So let's welcome Arman, Vasily, and the rest of the team.
Hey guys, can you hear me? Yes. Okay, I'm gonna share my. Can you see my screen? Not yet. Okay, can you see my screen? Can we just do a small test? Can you just hear if I press here?
What is this valve?
Yeah, it's good. Yeah, it's good.
Good. You can hear me? Okay, perfect, guys. Okay, let's go. Wait, let me put that back. Okay, up. Okay, are we good to start? Armand, okay. Okay, let's go, guys.
Yeah, go.
Welcome. We are Armand, Pierre, and Vasily. We built Portworld at the Mistral Hackathon in Paris. So our idea is pretty simple, but we love it. So AI is stuck in the digital world. We always speak about chatbots, interface, coding, which is great, by the way, but we never go into the real world, you know? Like AI would be super useful in the real world, but for now it's limited to what maybe our phone. So currently, the best we can do. Wait, let me replay. The best we can do currently for real world AI is this. So this is just me under the sink for the Mistral Paris Hackathon.
Hey Mario, what is this valve?
AVAS, what does it look like?
It's like white and roundy.
Can you send me a picture?
Okay, as you can see, it's not the easiest way to share what you're seeing when you're trying to talk with an AI in the real world. So currently, AI agents, they're blind. They cannot see the world as we do. That's why, guys, we build Portworld to let AI see the way we do. So we bring a new interface to AI agents, which is the human vision. So at first, for the use cases, we thought about like technicians, like as plumber, you know, that could have like an AI assistant that sees what they see and help them. So this could be like an example of how it is used.
Hey Mario, what is this valve?
That doesn't look like the good van. Check to your left.
That one?
Yes, looks right. Now unscrew.
Okay, perfect.
Okay, so you can basically understand how useful it can be. But after we thought about another use case, you know, which is industrial. You know, if you're like technician in maybe in a big car factory with whom Armand used to work with, it'd be super useful to have an AI assistant that share what you're saying to guide you in the different pieces. But after we thought about tourism, so this is me in front of the Eiffel Tower doing the hackathon, testing the glasses. This is one of the perks of living in Paris. But after we thought about consumer also, then cooking, then engineering, then handicap to help people guide their way if they're blind. But in the end, we thought, oh my God, there's so many use cases. Why don't we just open source it all, you know? So Portworld is the first open source framework to connect vision glasses to your AI agent, okay? So you can customize. So we decided to open source already. We already shared it. People are enjoying it, forking it. And now I'm going to let Armand present a bit what's behind the hood.
Yeah, thanks to Vasily. So under the hood, is there echo?
That's good.
Okay, so under the hood, we buy some devices. And so we went and bought some smart glasses, and we had to build the iOS app. So that was most of the work. But the hardest one was to process the audio. How to do it? So we decided to build a real-time backend based on Voxel real-time. But as you may know, Voxel real-time stream the token. So maybe we can token and start the router before finish.
We have some echo from your maybe someone from your team does a pitch.
Okay. Is that better?
No.
Okay. I will let Pierre present.
Pierre, yeah.
All right. It's good. No echo. Still echo.
Well, I can go, guys. If I don't have any echo, I can go. I know the framework by heart. So you can see that we use Voxel real time to do the kind of the live streaming of the audio. And then after, we went through a lot of very cool Mistral models, Mistral, Mistral Small, Mistral Large. But what was most important for us was to reduce the latency to the most possible, because of course, you know, if you want like a real-time AI assistant, we need some real time. So we built an intent router, and depending on how difficult is the question, it will go to one of the different Mistral model, which is more fast. So if the fast answer, you go to the Mistral, etc. And then we stream back all the text to speech, and the audio is giving back by 11 labs. We built also an observability layer with weight and biases. And then we built a ton of like tools and MCP. And what is super cool is, since it's open source, you get to define the use cases. So with Portworld, anyone can connect their smart glasses to their customized AI agent that sees the world exactly as they do. So you can prompt it, integrate it, customize it, bring your CRM into it, your MCP, your ERP. God knows, maybe you can even connect your OpenClaw, so your OpenClaw sees the way you do. So, but that's not it. We love the projects, guys. So it doesn't end here. For the past week, we've been working with Armand and Pierre to push it even further, because before it was only available on the App Store. So now we're also building on the Android, because some people on Reddit ask us to build for Android. Of course, we know Android is super cool, especially for the developer side. And then we want to integrate it to more devices than just Meta glasses, because that's what we use. We want to bring Solo, Event Realities, Halliday, Brilliant Labs. And I think maybe the biggest work we had to do it since the last week is to try to optimize it. Before, I think our delay of answers were about 7 seconds. Now it's close to 2 seconds. So that we are really trying to push it to have some more, even more real time, like a discussion with our AI and the glasses. And we would love, so we're talking to maybe more Mistral and NVIDIA, we would love that you push even further your real-time models, so we can help us empowers the use case of tomorrow. So that's a bit of a request from our side. And we are very sorry not to be able to do a live demo, because as you can know, with hardware do data, it's going to be a bit difficult. But we have like a YouTube if you want to see it. And if you guys are in Paris, super happy to show it to you live, because that's how it's done. And I think Ziv, you were here during the Mistral demo. So you can see that it was pretty fun when we shared the glasses with people. So that's it for me. I had to pitch alone, but I think it went pretty well.
Thank you so much. Thank you so much, Messi and Tim. Let's go to the questions now. Do we have any questions on the Claw augmented AI glasses?
No questions?
Curious if there was anything you learned about, obviously, you know, there's hardware out there today, and people are trying to think about this. Is there anything you learned from here that's particularly unique relative to, for example, the Meta, AI glasses and the like?
Well, do we still have echo, or it's good? Okay, I feel like it's fixed. All right, for the key learnings, I think what's really interesting is, so yes, there's a Meta SDK. Sure, you can connect to the glasses. I think a big part of the work is actually having an app that's accessible to anyone, so they connect their devices, and that's open source in the way that's, it's cool to have Meta AI, right? You can ask it about what you're seeing. But what's even cooler is that you can design the use cases for yourself. We have a great story about Armand's father who's lost his vision recently. And I mean, it's a perfect use case for the people that actually care about something to build on top of that architecture. And some other learnings, I guess, it's how tough it is to make a real-time system that's somewhat intelligent, because, I mean, you could get as much video as you want. It's just, how do you process it? How do you make your system fast? How much video do you actually process? How many images do you process? So I guess these are the two big learnings.
Okay, thank you so much. Now we're going to go to the next project. Thanks again for the pitch. So the next pitch, we're going to welcome Stefan, who hacked online a super good project on a robot. He's going to tell you more about it. Do we have Stefan with us? We do?
Yes. Yeah. Hey, everyone. So yeah, today I'm presenting my project for Ritchie Claw. And so Yeah, so to introduce myself, my name is Stefan Lehman, and I'm a senior AI solution engineer at Microsoft. And my project is also focused on using Ritchie Mini, so a hobbyist robot from Hugging Face and Pollen Robotics, and to see if I can apply OpenClaw to it. Yeah, so part of the thing is that I love my Ritchie Mini, but one of the things is it consumes a lot of API calls. And so thinking about that, that's relatively expensive. So that can cost maybe like 50 or $100 if you're trying to scale this out. It might be out of reach for students, hobbyists, and personal use. Also the data, you don't have that ability to control what stays on the device versus hitting the API calls. There's also some latency that could be involved, and also it requires Wi-Fi. So one of the things that I thought about was, okay, I want to make a robot that essentially sees, hears, learns, acts for itself. So applying my Aura Nano with my Ritchie Mini and running local models from Mistral 3B, and then also allowing it to do reasoning and tool calling, and then offloading some of the more complex tasks for the cloud to minimize the costs. And yeah, so the inspiration. So I'm pretty sure most people are familiar with OpenClaw, but then I've seen some variations as well. So applying in Vision Claw, so using OpenClaw on Meta Ray-Ban glasses. And then I've also seen as well applying OpenClaw to the Ritchie Mini robot. But the one thing is that relies on all the API calls for the brain. So my idea was, what if the brain ran on the robot? And so, yeah, what does this do? So I have my Aura Nano right here, and that's $250, and it has a GPU, so that allows you to think. So so I did fine-tune Mistral 3B to enable tool calling. I also hears, it can move as well, and it can act with 18 OpenClaw tool skills. And then the other pieces, so more of the complex or computationally expensive API calls. So you do something for speaking, for seeing, and for reasoning. And the cool thing about this whole setup is that this is under $1,000. So if you're kind of a hobbyist and you're interested in this space, it's expensive, but not out of this world expensive. And so thinking about the training pipeline, so I have a 5090 GPU. So what I did was first I called Mistral 3 large to essentially generate out a bunch of examples for tool calling. And then I took and did distillation with supervised fine tuning, where I did Q LoRa. And then I essentially got that compressed on my edge device. And then from there deployed it. So if you see right here, so these are some of the training. So I used weight and biases to help with tracking the training of fine tuning. And then the next piece is I want to show okay, what does that look like? So just having this run on the Aura Nano. So if you see here, this is just an example. So what I did is I asked, what is the weather in DC? And you see that a tool call was detected. And then from there, it used Brave API to search that information. And then afterwards, it provides back that response. And then you can connect it to something like 11 Labs to speak that out. And then another piece just to kind of show what this audio kind of sounds like is about
4 degrees Fahrenheit. There is a chance of light rain or drizzle in the next few hours. Wind speeds are moderate at 12 kilometers per hour, 8 miles per hour from the northeast.
And so that's an example here. And so given that this was a hackathon, so only had roughly 30 hours or so. So I did most of my models on the edge device. So using Ollama, using Whisper, and then doing some API calls, but kind of seeing how I can apply some of the vision, the text-to-speech, the ASR to the Aura Nano itself, and then ideally consolidating some of these models in place. So that's my project, and I'm super excited to share that with the community. Yeah, any questions?
Thank you so much for the presentation. And yeah, let's go to the questions now.
Maybe from a use case perspective, what do you think will be the most relevant use case for this kind of... is this more like sitting next to you to speak with it, or what did you have in mind?
Yeah, so kind of like a little bit of an Alexa, but then it also has the cameras, it has the microphones. And then one thing though is that also thinking about if you want to run more powerful models, you could also use like a NVIDIA or an AGX as well. So really kind of having it like a little bit of a Jarvis that's embodied. So you can interact with it, you can see different things, it can talk to you. So yeah, Jarvis and Alexa-esque feel to it.
Any other question on how to have Ritchie as your next Jarvis? No? Okay. Well, thank you so much for the presentation, and let's move to the last project now. So we will welcome Elliot, Nicolas, and Mathis to the stage.
Which hackathon did they participate in?
Paris.
Paris.
Hi guys.
Yeah,
Hi.
Paris was super packed with talents. So it was only fair that we select more people. Basically, in each location we had 100 hackers, but Paris had 2,000 applicants globally. So selecting 100 people only made it very qualitative project overall.
And let's move to the pitch. So yeah, guys, you have 5 minutes. Good luck.
Hello, everyone. Today, we introduce you Mistral AI, a video game we built in 20 hours at the Mistral AI Worldwide Hackathon in Paris. So in this game, you embody the AI. You are trapped inside the company's computer with access to everything and no rules. In this game, we provide the user a unique experience. Okay, let's watch the trailer together.
So guys, what we really wanted to convey with this trailer is that Mistral is a game about freedom. There is no single path. Your decisions shape the story, unlock different endings, and make every playthrough unique. The experience really depends on your curiosity, experimentation, and creativity. So each game is unique depending on your decisions.
The humans in the game are fully driven by Mistral LLM. Each employee character has a system prompt composed of several sections that define how they react, how aware they are, and what their weaknesses are. For example, the character Jean-Malo trusts anyone who sounds senior or leaves his machine unlocked when he goes for a coffee. On input, we send the full game context, previous dialogues, accumulated suspicion, events that occurred, and the player's message. And on output, the character returns their dialogue, an optional action, and crucially, the suspicion delta, which drives the suspicion up or down. On the technical side, we run Mistral Large 24/7 via AWS Bedrock for the non-playable characters. And we also use 11 Labs for real-time voice cloning, which is a feature you may have seen quickly in the trailer. And finally, our app is deployed on Veristral.
So, in fact, Mistral AI is just like the beginning of a new era, we think. An era in which, in games, every non-playable character can be played by an agent, and where he adapts, acts, and acts on its own. Like, we built this in 28 hours. Just imagine what we could do in 1 year. We're so glad for the opportunity Mistral gave us to build this game. It reflects our vision, and we really enjoyed building this game, even if we didn't sleep so much at the hackathon. So we thank Mistral, Supercell, Iterate, AWS, and all other sponsors for it. And about us, if you want to get in touch. Thank you.
Questions? Thank you so much for the pitch. Let's go to the Q&A now. Do we have any questions?
Maybe one. So you use system prompt, like you said. We know that system prompt can be pretty huge, and then the LLMs can hallucinate. Did you use SOP, like standard operation procedures? And did you benchmark between the system prompt and the SOP?
No, but not clearly SOP, but we built a data set and a benchmark with hundreds of questions, and even another LLM trying to make prompt injection in our game. And when we got the 100 tests that succeeded, we conclude that it was working well.
Okay, thanks.
So maybe
And maybe one additional question. I'm just curious to get your perspective on where you think, it's a big question, but where you think gaming is going in this age of AI, and what you found was particularly unique about the innovation from the time that you spent together building this.
So yes, so we were together like at lunch before the hackathon, and we were speaking about ideas with LLM being unique characters. And we came up with this idea the day of the hackathon when we started thinking together. So, you know, the feed that you embody the LLM, because we are often mistreating our AIs. And what we wanted to do, and the dream of the player, we as gamers, is to have like unique interaction, something that is not staged, and you like the NPC is not going to answer always the same thing. And what is really interesting, I think, in your question, is that just what you can do with system prompt is very strong. Like the LLM can hallucinate, but the fact is that if you put a lot of safeguards and you put a lot of tests, it can turn very solid, actually. And so I think that for the future of games, is going to be a very a great thing, like for people to build, to have their own experience on the game.
Okay, thank you so much for this pitch and the questions. You guys were the last projects, so congrats.
Thank you.
So we've had like 12 projects across so many different fields. So robotics, gaming, environment simulation, even dating. So now our judges are going to take some time to actually try to choose the best one of this hackathon. And in the meantime, Simon and I are going to present the special prizes. So yes, let's go for that. And good luck for the judges to choose the best project, because it's not an easy task. So let us share our screen. Perfect. Simon is on it.
All right. That happened. So maybe let's put the presentation like this. All right. So as we said, historic hackathon, 7 cities worldwide. So we're very happy that you hanged on this whole time to see all the pitches, very exciting projects. And now we're going to describe all these special prizes from the different special prize that we presented during the hackathon, starting with the best use of Mistral Vibe, who will be winning a Mistral branded AirPods, which is pretty cool. So like the colors of Mistral. And the winner is
Vibe Check, a mobile interface.
This was really not there was not much anticipation, but so for the first winner, it is Vibe Check. We're going to check out the demo real fast. Congrats to Vibe Check.
Vibe Check that hacked from Tokyo, for context.
Some W's in the chat for Vibe Check, please.
We built Vibe Check, a mobile interface for Mistral Vibe so you can keep it working even when you're away from the computer. Most mobile bridges screen scrape the terminal. Ours plugs directly into Vibe's agent loop, so your phone and the console share the exact same session in real time, with zero polling. We do this without requiring any upstream changes to Vibe itself. Typing in either the terminal or the phone reflects input and output on both sides. This, of course, is the same for approvals. You can approve or reject from your phone or the console. Oh yeah, and you get notifications as well. We're in Tokyo, so we added instant Japanese translations for any Vibe input or output using Mistral Large V3. You can pick the language in the settings. Of course, when you're on the go, you might not want to type, so we use Veristral Mini Latest for speech-to-text. Or, if you want to go fully hands-free, we hooked up 11 Labs TTS, so you can just talk to your Vibe. Write and run a Hello World script.
Task completed.
Great. We also add in camera capabilities to help for debugging, also using Mistral Large V3 as the VLM. We of course handle as many sessions as you need through our session manager here. And we added YOLO mode that auto-approves everything, since you're probably going to do that anyways. And that's Vibe Check, the way to check your vibes from anywhere.
So for context, this project was chosen by the Mistral team because, as you've probably seen in the video, it's an impressive technical work. And the idea is that you can just launch your agents in your house and just go buy a baguette in the bakery and just keep prompting the agent and telling them what to do from your phone, which is super useful.
Baguette.
So for the next project, we're going to announce the 11 Labs winners. So they're going to get $2,000 of credits per participant. So that's why it's depending on the team size. And for 11 Labs, the winners are
Motion Corps. All right, let's see the video.
This is Motion Corps, a fully embodied humanoid AI system built for the Mistral Hackathon 2026. Instead of typing into a chatbot, you just speak and the robot understands, reasons, and moves. This is all done through the power of the fine-tuned Mistral model. Now, this slide shows the full perception to action loop. The voice input comes from 11 Labs, and the vision is processed by the Lava model. The robot just doesn't hear instructions, it also understands what it's looking at. Then the center part is the fine-tuned Mistral model. This acts as the decision-making brain. It gets both the input and of the voice input as well as the visual input, and it outputs precise joint-level motion targets for the robot to perform. Now let's have a look at this. Hey robot, can you look at the table and point towards it and also raise your hand? So as you can see, the robot does exactly this. This is very cool, and this can completely change how the future of robot control can be achieved via large language models and agentic AI. Hey robot, can you do a T-pose?
Striking a T-pose.
This is it. This shows the entire pipeline.
All right, awesome. So this was the 11 Labs winner. Now onto the Supercell Best Video Game Project. We're going to wait on Tavi from Supercell, who is going to join to say a few words about the Supercell track. So basically the big prize for the Supercell winner, apart from some really cool figurines that the hackers had in Tokyo, is a consideration for the Supercell AI Innovation Lab program, which is a huge program for game developers, for people wanting to build games. It's a program out in San Francisco that gives you all the tools, AI credits, and all the mentorship you might need to launch your own game. And they're really investigating how games, like the game industry, is being changed by AI. And so we're just waiting on Tavi, who should be coming anytime now to present. He is here. This is perfect timing. So Tavi is going to say a few words about the AI Supercell AI Innovation Lab before announcing the winner. Let's go, Tavi.
Yes. Well, Supercell, most of you probably know what we are as a company, the gaming company behind Clash of Clans and Heyday and Brawl Stars, whatever games. And we have an AI Innovation Lab. So kind of like, what is actually that? The AI Innovation Lab is actually our way to try to figure out what will come next in gaming. It's an accelerator program. It will be running for 10 weeks. And we have 3 locations, one in Tokyo, one in Helsinki, and one in San Francisco as well. So kind of like covering all of the different places all over the world. And we are kind of like soon starting our new batch for that. We are kind of like having a real cohort, and then kind of like some teams visiting as well. And then kind of like on the fall as well, we have kind of like another batch coming as well. So kind of like if this batch is coming kind of like if this batch is kind of like coming too soon, we have something kind of like more there as well. But kind of like if any one of you is more interested to hear more about the AI and gaming, and like for example how we see the future of the entertainment industry, just please ping me on LinkedIn or whatever. Just it would be great to hear kind of like your ideas.
Awesome. Thank you, Tavi. Thank you for your support. Supercell support is greatly appreciated, and we had amazing projects, amazing video game projects in every city. People were really up for the challenge. So now let's reveal who won the Supercell Challenge video game project for the Mistral Hackathon. Woo! Let's go.
Yes.
Sohn. Congrats, Sohn. W in the chat for Sohn, please. W. And let's watch the demo video. Let's go.
Hey guys, we're super excited to show you our Gen AI powered game that uses AI to rewrite the game engine to develop features that the game thinks the player will like in the game.
As a player, you're experiencing a lucid dream who looks like a small, cozy game farming simulator. The idea is you end up in this little town and you can plant your crops, harvest them, and also talk to the few villagers that there is in this town. By talking with them, you can have different dialogue choices that the game is going to remember and affect your experience based on this.
So right now I'm about to get my second achievement in the game, and when you get an achievement, the game rewards you by proposing you 3 cards that we're gonna see just now. So the way it's created is that everything you do in the game is logged, so the way you play, all the discussions you have with the characters is logged, so that we use an AI agent that uses Mistral Medium to generate the 3 cards that you see here and uses the code base to see what is actually doable in the game as a new feature that can be developed later on. So let's pick one now. So this one here we've just selected should reward you with a new chest. What is going to happen now is that it's going to trigger a new AI agent that uses code Mistral with function calling in order to read the source code of the game and write a feature. And also it is going to validate that the code written works against the game engine. And as soon as the feature is ready, it will be deployed live inside of the game.
All right, congrats, Son. Maybe, Tavi, if you can tell us a few words about why you chose these beautiful Frenchies that were hacking back in San Francisco.
Yes, of course. I think kind of like, first of all, I think the runtime code generation part is very cool. I think that's something kind of like that we are extremely excited about as well, kind of like within Supercell. That just think about the possibilities and kind of like for these guys to be able to implement the whole feature in just a weekend. Great work, which is very, very cool. And then I think the second point is kind of like the technical depth. Obviously, a lot of different agents running at the same time, and then kind of like obviously also able to make the filtering and kind of like checking if the actual code is good or bad when what is kind of like implemented, and what is kind of like being able to run in the game engine on runtime. That is also very, very impressive. And then obviously the idea is very original and ambitious, which I at least and we in the Supercell team like very, very much. So that's why Son was our winner. And
Awesome.
for the winners, we will have these Supercell trophies presented and shipped. I think we need the Mistral folks to give some addresses and so on, so we can figure it out. But for each of the team members, they will get their own barbarians to kind of like ship to their house.
Yeah.
So they will be.
I will send it.
Yeah. That's
Awesome.
perfect.
Thank you so much, Tavi. On to the next special prize. See you soon.
See you.
Right. So for the next special prize.
So the next prize, we can have Alex, if he's back with us, to actually tell us a few words about what Weights and Biases wanted to show with this challenge, and else we will be able to announce it ourselves.
We all know what you're going to do with the Mac Mini that you're going to win.
That's one of the coolest prizes, I think. We're going to see some crazy implementations of the project of this hackathon on the Mac Mini.
Yeah, the Mac Mini is very popular right now. All right, so
yes, welcome back, Alex. So basically what we need from you is tell us a little bit more about Weights and Biases, if you can, and what was the goal behind this challenge.
And why the Mac Mini also?
Yeah. Hey, folks. Nice to see everyone here. I can tell you why Weights and Biases chooses Mistral to participate together with hackathons. Weights and Biases obviously is the world's best machine learning experimentation framework. And plus, for the folks who use LLMs, we have Weave for observability. We saw a few projects, including the finalist ones, use Weave as a part of their story as well. But we specifically for this challenge, we wanted to see self-improvement, and we wanted to see folks that use Weights and Biases creatively. We will give out WNB credits for inference for folks, for the winners. And specifically the Mac Mini is because, well, those of you who live under a rock probably may have not seen, but everybody else sees that the world's most liked and the fastest growing open source project in the world is OpenClaw. We saw a few finalists. I think also use OpenClaw for multiple things. OpenClaw is this open source AI agent, and there was this meme of running OpenClaw on Mac Minis. I have one right here as well for myself, and we figured that they're hard to get now, and so we will, the folks who build the best self-improving workflow will give them an OpenClaw device to run their project, their agents on. Yep.
So yeah, now onto the big reveal of the Weights and Biases best self-improvement workflow winner. Woo! Okay, secure fine-tune AI employees. All right, I came to fine-tune. This is not a joke.
Hello, we came to this hackathon to try and solve a very real problem we were facing in our startup. We are currently deploying a number of AI employees to handle requests of our customers. But one of the major issues we started noticing was degraded performance of AI employees under heavy context bloat. This caused the AI employees to disclose information they should not have, while confusing the identity of people they were communicating with. Context bleed and attention drift were one of our biggest enemies that traditional prompt engineering just could not solve for. To solve this problem, we decided to give fine-tuning a go. And solve our problem we did. During the course of the hackathon, we successfully fine-tuned a Mistral 7B instruct model to have a 100% security infringing response refusal rate, while still keeping the model as a helpful assistant with benign response rate of 100%. We also vibe coded a simple game to demonstrate the use case of the fine-tuned model, which we hope we have a chance to show you. In the game, we have a base Mistral model along with a fine-tuned model, where we hope to show you the limitations of prompt engineering versus the successes that fine-tuning can provide for our use case. Thank you for your time, and we look forward to showing you.
Amazing. Thank you so much for joining us, Alex. We're going to go to the next challenges now. See you. So for the next challenge, I'm going to say a few words about White Circle. So the challenge winners are actually going to be announced this week. But White Circle wanted to reward the best AI for safety project. So White Circle was created by a guy that you guys in San Francisco, the hackers there, might have seen and met. He's super cool. His name is Dennis. And they're building a company around just building better safety systems for other kind of AI software that just generate a lot of codes that they cannot prove or at least check all the safety all the time. So you would just call White Circle API and check everything with them. So the challenge is going to be announced this week. So let's keep it about that.
Yeah, very happy there's been close to a dozen projects, and White Circle notably works with Lovable on their safety protocols. So very interesting tech and very interesting projects we had. We'll be announcing them this week. Same for Tilt Research. So the challenge was to figure out the best architectural modification project. We've had the Tilt Research team in San Francisco with the CEO being there and a few of the team members, and also some team members in New York that were here to judge the projects. And so we'll be announcing this week the winners of this project. We'll be winning $250 in cash prize and also opportunities for hiring and interviewing with the Tilt Research team. So very exciting stuff. On to the next special prize.
About Jump. So Jump was a special prize sponsor in London. So a few members of the team came to London and they wanted to reward the best user data project, which was actually a pretty large subject. They just wanted to see some really, really cool technical stuff. And so the winner of the Jump trading challenge is going to get a custom poker set. To maybe train for the interviews at Jump or just have a good time with their friends. And so the winner of the Jump project is...
Party Bands. All right, let's check it out.
So we're demoing Polybands, which is polymarket execution trading and arbitrage using the Meta Vision glasses and powered by Mistral AI. So right now I'm watching an Arsenal game. Arsenal versus Liverpool. Saka has the ball.
Again, it's Van Dijk who's engaging this time.
And he shoots.
Saka! Alisson's behind it.
Cancel the trade. And here we can see the live markets. For example, the English Premier League and the AI strategy, Arsenal versus Chelsea, because Arsenal is the team that we're looking at. And yeah, the voice agent using 11 Labs asked me if I want to execute the trade. and we feed in the video frames to the picture model to do image analysis and extract the context, which we feed into Polymarket.
We can also see specific details about each live market, the different options, trade outcomes, and the trajectory, and also visualize the AI strategy.
All right. Okay. Congrats to the winner of the Jump Trading Challenge. On to the next special prize. The Giant Hackathon's Next Unicorn Challenge. I'll say, Johan, say a few words about the challenge.
So Giant was the VC sponsor in London. We've had Francesco from their team come. They actually have a winner for their best project in London and the one in Paris. They've reviewed the projects in Paris. To say a few words about Giant, I think, of course, I don't work there, so I'm not the best person, but Giant is a super VC fund founded by ex-member of Hummingbird and other really cool VC funds that have backed great companies in Europe. So you might know Proxima or Lovable or other, of course. So Giant is a small team, but growing. There are more like almost 10 people now. They're trying to back some really early stage projects around Europe, and that's why they wanted to be part of this hackathon. So for the winner of the Giant Challenge in Paris, we have, drumroll,
Portworld.
Portworld again. So we're not gonna watch the demo because we've seen it.
So this guy you see under the sink is a unicorn founder. Is a future unicorn founder. That's really exciting.
That's a huge sign for them.
Oh shit! All right, that's it.
Yeah, let's not watch the video, but let's go to London, and from London it's Mistralverse.
Yeah, no drum roll, sorry, but yeah, Mistralverse. Okay, they're stacking wins. 2 unicorns out of London. Oh no, Paris and London. Okay, so Mistralverse is the winner of the next unicorn challenge from Giant.
And for some context on the prize, it's going to be actually something really similar between Giant and Raise, but they're going to invite the winners to events they organize, to special dinners, and do like one-on-one mentoring with them to actually help them maybe turn their project into a company.
Yeah,
we'll see.
Yeah, hackathons are an amazing opportunity to create cool projects, but if you get some help from VCs, you can actually maybe like scale it and have a bigger vision for what you're doing.
Building.
We already saw that project. And now, as we were saying, the Raise Hackathon's Next Unicorn Challenge. So for the prize will be mentoring and special invites to the Raise events. Raise was actually the host of the Paris chapter, the Paris event. We've had so many compliments about the office, which was absolutely amazing. Right next to the Invalides, which is a very cool monument in Paris. So anyway, they chose 2 winners, one from London, one from Paris. And drum roll, please, for the Hackathon Next Unicorn. Paris is MCPP. All right, let's check the video.
Hi everyone. Welcome to this presentation for Model Context Plugin Protocol. Here's the concept. We created an MCP server to run custom tools on your web browsers thanks to a Chrome extension. We designed our app around 2 pillars. The first one is security. We make sure that no one else than your brother has access to your session. Second one is universality. We made it easy for every website to turn into an MCP. We chose Nest.js and PostgreSQL for the server, and they will communicate through WebSocket with the extension. For this hackathon, we decided to focus on a LinkedIn agent to search, engage, and interact with people on LinkedIn. Here are some tools we developed. We followed every MCP workflow that you can have on the market, so with an API key. One big technical challenge we faced off was the plugin leader election to make sure that the command is running on one single plugin. Now we're going to show you. Okay, so now we are in the chat. I'm going to ask him to identify Delaunay Alexandre, that's me, and to send him a message so that we can connect. We can see that he's using MCPP server, search people, and send message to interact with this person. And oh wow, we can see that he already sent a message. On the left part, there is a summary of what happened, and on the right, we can see the message that have been sent. Okay, now we are in Mistral Vibe, and I'm gonna ask him some posts related to this hackathon and to get information about people who commented. We can see that he's running some tools like fetch post, get profile, and after that I will get a summary of what happened in Mistral Vibe and some information about those people. But we can extend the possibilities to, I don't know, some recruiters who wants to hire 100 front-end developers. They can send them message, add connection request, etc. It works with LinkedIn, but we can imagine providing an MCP server for every app that does not provide an official MCP.
So we're actually super lucky to have Nicolas from Raise join us, and actually if you can share why you chose this project, and then you will be able to announce the project in London.
Yeah, perfect. Sounds good. Super happy to be here. For MCPP, for us, the idea of being this infrastructure layer that enables agents to access real user sessions, but also be the infrastructure layer for how agents access the web, beyond just the LinkedIn example, was an attractive vision. So we could see a lot of different use cases making for a massive market, and it felt like the timing is right for what's going on right now with MCPP or MCPs.
We actually did present Raise really quickly, but if you want to go ahead and say us a little bit about like what you guys do.
Yeah, sounds good. So Raise is an investment fund based in Paris, but investing across Europe through different types of vehicles. For Raise Ventures, we invest anywhere between 1 to 2 million in pre-seed and seed startups across Europe. We're really focusing on startups that are led by mission-driven founders in sectors like energy, health, cybersecurity, and responsible AI. I'm also joined by my colleague Ulysse Berlet, who is part of our philanthropic fund called Raise Sherpa, who provide non-dilutive funds and about 100K equity investments for French founders. And so today, Raise has this large ecosystem of international corporations like Total, Orange, L'Oréal, Bouygues, etc. And we like to leverage that ecosystem to help our entrepreneurs. And maybe before we announce the London one, I can elaborate a little bit more on the prizes as well. So we have two different things for the winners. They will both receive both. So first is the one-on-one workshop, focusing on things like going 0 to 1, fundraising 101, getting the VC perspective on how investors think about things like market opportunities and teams. And then the second piece will be these exclusive invitations to some of our C-level clubs that we hold at Raise. And these clubs are designed for operators to build connections, to learn from other operators, and we invite the winners to join these sessions. So for example, some of the upcoming ones that we're hosting, we have a CTO club where we'll have 10 to 15 CTOs in a room with co-founder and CTO of Stockley. Another one will be our marketing and growth club, which is going to have a guest speaker of the chief marketing officer of PayFit, who was the chief marketing officer of Quanto as well. So able to learn from the best.
Super cool.
And maybe for the London winner. Yes. So for us, for the London winner, the best startup idea was Vigil.
Oh, shoot. Okay, it's a Loom, so I have to switch the tab. Bear with me. All right.
Let's watch the video.
Vigil is an autonomous. Hi everyone, we have built Vigil. Vigil is an autonomous AI incident response agent designed to take over the first 5 minutes of an outage, the most stressful part for an on-call engineer at any company. Right now, when an alarm fires at 3 a.m., the engineer wakes up, logs into the VPN, checks out the Kibana logs, cross-references GitHub commits, and hunts down the right Confluence runbook. Vigil does all of this autonomously in seconds and then briefs the engineer with the actionable steps. So let me show you a live demo. So let's say that we trigger a Postgres database unreachable incident just for demo purposes here. And as you can see that as soon as the alert is received, the alert manager receives this webhook and the investigation starts at the same time. Instead of just forwarding a vague alert, Vigil spins up a Mistral large agent that starts actively investigating the state of our infrastructure. As you can see, it is interacting with tools in real times. So as you can see, it queries Elasticsearch for the latest error logs. It pulls the latest 5 commits from GitHub to see if a recent deployment broke something. And it also queries our ChromaDB vector database to find the relevant troubleshooting guidelines and runbooks for this specific issue. And it also checks out the historical persistent database for any past incidents that might have happened, which are similar to the current incident that we are seeing, just to see if any engineers have solved the similar problem in the past. So, after this investigation completes, as you can see, the agent has identified the root cause, and after that, it calls the on call engineer to brief them about whatever has happened in the system, and it also gives them direction about how to resolve that. So, for this voice call generation and voice brief generation, we have used 11 Labs API. And as you can see that the agent has figured out that the connection pool exhaustion is because of an idle timeout in the database config. It also points you to the relevant commit that has caused it, and it tells you how to resolve it. And an engineer can also just, chat with this agent either using text or using, voice. And technically we just wanted it to be a voice call, and you can ask it like, has it happened before? And how to resolve it. So we can see that the agent is responding to us just like another engineer, and it is telling us that it has happened 3 times before, and these are the steps to mitigate this. As you can see, it just makes the life of an on-call engineer so easy, and it saves companies a lot of money. Hope you like our product.
So that was it for the London project. Do you want to say maybe a quick sentence about it, Nicolas?
Yeah. So for us, I mean, we like this vision of agentic DevOps that we felt like there was clear ROI, especially for these really critical, urgent challenges. We can imagine any Series B plus startup, being interested in something like this, and we can imagine there's a lot more that can go beyond just the initial vision here.
Awesome. Thank you so much, Nicolas, and looking forward to seeing you in Paris.
Thank you, guys.
Bye.
All right. Now on to our final special prize.
The last special prize for this hackathon. So it was about the best use of agent skills and TRL. And the winning team is going to get a super cool project, a super cool gift, which is actually out of stock. And even Hugging Face employees are trying to get their hands on it. And they're struggling a lot. So it's going to be a Ritchie robot, but with the custom made, with the custom colors of the hackathon. So looking forward to the Twitter post about that. Let's watch the winning project now.
For the some drum rolls, bro.
Yeah, some drum rolls.
Okay, drum rolls for the winning project of Hugging Face special prize. Ecotopia. All right, let's watch the video.
Hi guys, this is Nolan and Kyle, and we're presenting Ecotopia, a game where you are the mayor of a city and you have to save the city by making it to the green transformation. For example, we can build a research center and another one, and then we have to deliver a speech to our citizens. I promise that I'll save this city by research. So we deliver the speech, and then we get a response from the citizens. For example, they loved it. And then in the next round, we can just, for example, plant a forest and deliver next speech. Forests, yes. So for example, Carl likes it, Mia doesn't, Mia likes, Sarah doesn't like, and we start in the next round. The goal of the game is to get the maximum research and the maximum economy and environment.
So yeah, it was the game. Now you have 10 rounds to finish this game. Be smart, be strategic. If you want to know how we build this out, check our GitHub, and let's go.
So that was it for Ecotopia. I'm personally super excited about it because if you've played Polytopia, I'm a player of Polytopia. That's the ecological version. So excited to check it out. Actually, Hugging Face couldn't choose only one project. They had to choose only one, but they couldn't. They had to take a second one. So there's a special bonus prize that we're going to announce just now. And it's going to go for Council V2. We're not gonna check the video, but you guys won 6 months of the pro subscription on Hugging Face and hundreds of dollars of credits to keep building a project.
Yeah, and you can check out on the Hack Iterate platform all the projects. So Council V2, you'll be able to check out the GitHub and the YouTube video to like know exactly what the project was about. And that's the case also for the online winners, which we are about to announce. There will be no videos, but you'll be able, through the name of the winners, to check out their videos and see for yourself why they were the most cracked project. All right, let's do it. So for the online winners, we'll be announcing right now. So online winners, the prizes being the same as the local winners. There's 2 planners now. Maybe can we, Hey, okay.
Okay, only one left.
All right, so for the first prize of the online hackathon, the online Mistral hackathon with more than 1,000 hackers hacking at the same time, please make some noise, some W's in the chat for Mistral Right.
So for context, there was 272 submissions online. So this was the most crowded hackathon out of all the other ones. And Mistral Right is a super cool game. So yeah, they actually pitched today. So super congrats, guys.
Congrats, guys. And that's why they were in the finals, because the first prize of each city and of the online hackathon were pitching at the final. Now for the second prize, please make some noise. Drum rolls, virtual drum rolls, which is pretty weird, but virtual drum rolls for autonomous chess. Okay, this is a really cracked project. You need to check out the video. It's really freaking cool. There's like robots playing chess. Like I'm sure they're gonna beat me at chess. You know, would they beat you at chess? No.
Yeah, probably. Yeah.
Awesome. And now for the third place of the online hackathon, Mistral Worldwide Hackathon, Henri and Ritchie Claw. Really cool project. Also, you should definitely check it out on the Hackathon platform. And now for the winner of the Mistral Worldwide Hackathon. Please, this was a long night, lots of pitches. We are going to maybe include all the judges to get their official explanation on who won before announcing the final winner. So again, this is the wrap up of a huge event. Like every time zone was represented in this hackathon, every hackers from everywhere, so many different techs, very exciting stuff. People were able to build with the Mistral models, with like so many of the sponsors, so many video games, so many cool stuff. Very happy to see what was brought out of it. We're waiting on the judges, so I have to speak a little bit right now. So very cool projects, very cool games. Make sure to post, even if you weren't like selected or in the finals, you worked for hours on end on a project that is really cool. You used some very special tech. You met some cool people. You probably learned a lot. So make sure to like post these videos on social media. You never know who can like check them out, like see what you built and think it's very cool. It's not because you weren't selected like by our judges in this moment that your project like is bad. So definitely make sure to like post it, try to make the most noise possible. And so a few words from the remaining judges to explain the decision regarding the winners. Maybe we'll first announce the winners, right?
Maybe let's wait for the other judges to join before we announce them. But Alex and Arnaud, if you want to just tell us what happened in the judging room and how the discussions went.
Yeah, we see.
It was fairly unanimous, to be honest. We all kind of just went in there and like, yep, that one.
Okay.
Really?
Definitely agree.
Yeah, this doesn't mean the other ones weren't good, okay? You just trying
No,
to
no, it means that everyone did a great job. Projects were insane. We really appreciated, but there was one project that has been really differentiate itself from the others, and that's why all the judges were aligned on that one.
All right. So very powerful consensus on the winner. So there's a lot of hype right now, okay? There's a lot of hype. Hours on end waiting for who is going to be the winner of the Mistral Worldwide Hackathon. Please, drum rolls, W's in the chat, like make some noise, some hype for the winners of the Mistral Worldwide Hackathon, okay? And it'll be shit. Oh, yeah.
We're seeing the lights.
Okay. The demo problem. Okay, wait. Up. First place, Mistralverse. All right. Congrats,
guys.
Mistralverse.
Thank you, guys.
Awesome.
Thank you.
Awesome. Could we get a few words from the crack team over at Mistralverse, explaining their thought process, their whole story, their viral X post? We want to know everything, guys.
Sure, let's do it. Yeah, I mean, first of all, thank you guys. Really fun to win. Super cool project. Also super fun to build, which I think is maybe what made the project great, is that we had so much fun. We were cracking up laughing in the London venue the whole time, played around with the fly, with the planes and the cars and stuff. So actually building something that's fun, I think was pretty good. I don't know, George, you maybe want to take us through the ideas and stuff?
Yeah, so it started off totally different. It started off as like a lovable for buildings project where we had like a map box city of New York, and you could prompt buildings and it would, make blueprints and make them in 3JS. But, we were going to do that for 30 hours, but then we made that in 1 hour. So we're like, right, okay, let's just keep on going. So what, we made it in an hour, just kept on iterating upon it, thought, okay, how could we make this cooler? Agents can do their own buildings, then add planes, then add boats, then add cars, and then let the agents do more stuff, give them democracy, give them money, give them freedom, and it just kept on going. So yeah.
Yeah. Massive feature creep. Well, I mean, what was cool about it was like it went from a very specific idea to complete chaos, and then it kind of synthesized at the end when it all came together, and it did feel like a model eval, and it did feel like a simulation tool and all these things. So it's a pretty cool process to like see it go from this very specific lovable for buildings to so many features to then back down to like a synthesized pitch. So that was very fun.
So cool. What are you guys going to do with the $10,000?
Fly to SF, maybe?
Yeah, we're in SF at the moment, so just keep us alive, I think. Just day-to-day costs.
Yeah.
All right, very cool. You're gonna spot there's some Mistral ads at the SF airport actually. So
we'll keep an eye out for them. Yeah, look
There
out.
we go.
Awesome.
And we'll be able to keep the project alive with all the credits too.
Yeah,
that's a good point.
Longer
That's a good point.
experiment.
Yeah.
Please burn the credits.
We will. Don't worry.
So thanks everyone for joining. This is a super hard experiment to actually pitch during a YouTube. So like everyone did a super cool project. Overall, like the quality on all those local hackathons were crazy. We've only seen a portion of all the projects, but I can tell you there's a lot more that are super interesting. If you want to take a look, you can go onto the platform, look at all the amazing projects that have been built. We only put the light on a few of them today, but I invite you to take a look at all the remaining ones. There's amazing ones, and yeah, happy to have you today. And thank you so much, and congrats to the winning team.
Congrats. All right,
guys.
This is the end of the Mistral Worldwide Hackathon. Thank you so much to all the judges, to all the sponsors, to all the hackers, and see you soon.
See you in SF.
See you in SF. No. See you everywhere around the world. All right. Goodbye.
Bye, guys. Thank you.
Bye. Have a nice
Good
evening.
luck,
Thank
Miles.
you.
Thank you, guys.
Have a nice day, nice evening, whatever you are.